Welcome to Get Your FRQ On. This question is from 2018. It is question 5, and it is not calculator active. In the question stem, we are given a function, f, equals e to the x times cosine x. And that's it. That is the question stem. We get a function. In part A of the question, we are asked to find the average rate of change of f on the interval from 0 to pi. To do that, we can just use the formula for average rate of change. We're going to do f of pi minus f of 0 over pi minus 0. And then just substitute the values in. We're going to have e to the pi times cosine pi minus e to the 0 cosine 0 over pi minus 0. E to the pi times cosine pi. Well, cosine pi is negative 1. Cosine 0 is 1, but e to the 0 is 1. So we get negative e to the pi minus 1 all over pi. You don't really have to do much else for this one. It's straightforward calculation. In part B, we are asked to find the slope of the tangent line to f at the value x equals 3 pi halves. All right, well, if f is the function e to the x cosine x, in order to find the slope of the tangent line, we have to differentiate f. This would require use of the product rule. F prime of x is e to the x cosine x minus e to the x sine x. And notice you can factor out the e to the x there. And that becomes e to the x times cosine x minus sine x in parentheses. So to get the slope of the tangent to f at x equals 3 pi halves, we're going to evaluate f prime at 3 pi halves, which is going to be e to the 3 pi halves times cosine 3 pi halves minus sine 3 pi halves. Cosine 3 pi halves is 0. Sine 3 pi halves is negative 1. 0 minus negative 1 is positive 1. So we just get e to the 3 pi halves. All right, so the slope of the tangent line to f at x equals 3 pi halves is e to the 3 pi halves. In question C, we are asked to find an absolute minimum value of f on the interval from 0 to 2 pi and to justify. All right, well, our function f can have an absolute minimum either at an endpoint or somewhere between the endpoints where f prime of x is equal to 0 and changes sign from negative to positive. Notice that the function e to the x times cosine x is continuous on 0 to 2 pi, so we don't have to worry about any discontinuities. It's differentiable on the interval from 0 to 2 pi, so we don't have to worry about there being some point where it's not differentiable, but it still changes sign. We don't have to worry about any of that here. So we're just looking for values of x where f prime of x is 0 and changes sign from negative to positive. All right, well, we have a function, f prime of x, that's e to the x times cosine x minus sine x, and we are interested in setting that equal to 0. Now, a couple things to notice about this. Notice e to the x is never 0. So if e to the x times cosine x minus sine x is going to equal 0, it can't come from the e to the x. It has to be from the factor cosine x minus sine x. If that's the case, if that's going to be 0, then cosine x has to equal sine x, which means we are talking about x equals pi fourths or 5 pi fourths. How do we know which one? Well, that's when we determine whether or not the derivative changes from negative to positive. Well, f of 0 is e to the 0 times cosine 0. That's equal to 1. F of 2 pi is e to the 2 pi. F of pi fourths is square root of 2 over 2 times e to the pi fourths. And f of 5 pi fourths is negative root 2 over 2 times e to the 5 pi fourths. Now notice that of all 4 of these values, we did check both endpoints. When you find an absolute maximum or minimum, you need to check the endpoints. But 3 out of these 4 values are all positive. 1 is positive, e to the 2 pi is positive, square root of 2 over 2 times e to the pi fourths is going to be positive. The only one that's negative is f of 5 pi fourths. All right, well, that means it's less than the other 3. It's the only negative one. So our absolute minimum is going to be at 5 pi fourths, and the absolute minimum value would be negative root 2 over 2 times e to the 5 pi fourths. In part D of this question, we are given that g is a differentiable function. g of pi halves is equal to 0, and the derivative of g is provided in a graph. And we are asked to find the limit as x approaches pi halves of f of x over g of x. All right, since g is differentiable, g is continuous. Now, since g is continuous, by the definition of continuous, the limit as x approaches pi halves of g of x has to equal g of pi halves. Well, we're given in the statement of this part of the question that g of pi halves is 0. Okay. If I find the limit as x approaches pi halves of f of x, that would be e to the pi halves times cosine pi halves, which is equal to e to the pi halves times 0, so that is also 0. Which means that the limit we are looking for is indeterminate. Since it's indeterminate, we are expected to use L'Hopital's rule to calculate its value. All right, so the limit as x approaches pi halves of f of x over g of x is equal to the limit as x approaches pi halves of f prime of x over g prime of x, which would be e to the x times cosine x minus sine x all over g prime of x. Now notice, we don't have an explicit function for g prime of x. We only have the graph of its derivative. That's it. All right. But it's pretty obvious from the graph of its derivative that g prime of pi halves is just 2. All right, so the limit as x approaches pi halves of e to the x times cosine x minus sine x all over g prime of x should be negative e to the pi halves all over 2. All right, cosine of pi halves is 0. Sine of pi halves is 1. 0 minus 1 is negative 1. So we get negative e to the pi halves all over 2. It's important to understand when you are asked to find a limit in a free response question, if it requires the use of L'Hopital's rule, you must demonstrate that the indicated limit is indeterminate, either 0 over 0 or infinity over infinity. Don't write it as a fraction, 0 over 0. Don't write it as infinity over infinity. Show both limits separately, then declare that the limit is indeterminate, then proceed to use L'Hopital's rule.